Well, illustration number 3. Locate 2 root 2 on a number line. So dear friends, here I have made a square of 1 inch. All the sides are 1 inch. Considering a unit square OABC with each side 1 unit length. That means I have constructed a square of 1 inch and I have drawn it diagonal OB. Then by Pythagoras theorem, triangle OAB is the right angle triangle and measure angle A is equal to 90 degree. So hypotenuse OB square is equal to OA square plus AB square. OB square, OA is equal to 1 unit and AB is also 1 unit. So 1 square plus 1 square. So OB square is equal to 1 plus 1. OB, the square goes on the right hand side, it becomes square root. 1 plus 1 is 2, that is square root 2. Another method, representing root 2 on a number line. So dear friends, I have drawn a number line over here and I have taken OA is equal to 1 unit and AB perpendicular to OA, and that is also 1 unit. So now in triangle OAB, measure angle A is equal to 90 degree. OA is equal to 1 unit. AB is equal to 1 unit. So OB square, that is the hypotenuse, is OA square plus AB square is equal to 1 square plus 1 square. So OB is equal to root 2. Now using a compass, draw an arc with a center O. That means you are going to put the point of your rounder over here and you are going to take your pencil up till here and you are going to draw this arc which is cutting the line at point P, and point P represent root 2. Again you are going to place your rounder over here and you are going to take pencil up till here. So this becomes your radius and you are going to draw this arc intersecting the line at point P. So with center O and radius OB intersecting the number line at point P. Point P corresponds to the root 2 on the number line. So illustration number 4. Locate root 3 on the number line. So same way as we have done before, this sum root 2, same way you are going to locate root 2. That is in triangle I have taken OA is equal to 1 unit, AB is perpendicular to OA and OB is the hypotenuse. So in triangle OAB, measure angle A is equal to 90 degree, OA is equal to 1 unit and AB is equal to 1 unit. This is 1 unit, this is 1 unit. So hypotenuse OB square is equal to OA square plus AB square. It is 1 square plus 1 square. So OB square is equal to 1 plus 1. Square goes on the right hand side, it becomes square root. 1 plus 1 is 2, that is square root 2. Now same way you are going to put your rounder over here at point O and pencil, you are going to stretch your pencil up till point B and then you are going to draw a arc intersecting the line at point P which shows you root 2. Same thing I have written over here. Now with center O and radius OB, draw an arc intersecting the number line at point P, represent root 2. Now we are going to construct BD perpendicular to OB. That is from here you are going to take 90 degree. I have made the point of 90 degree over here using a protractor, and then you are going to draw BD of 1 inch, or that is of 1 unit. So BD, so now, and then you are going to draw OD. So in triangle OBD, measure angle B is equal to 90 degree. This is OB is equal to root 2, this is 1, and OD is the hypotenuse. Same thing, let BD is equal to 1 unit. Now according to Pythagoras theorem, triangle OBD, this one OBD is 90 degree and measure angle B is equal to 90. Measure angle B is equal to 90. Now OD square is equal to OB square plus BD square. OB is root 2 square plus 1 square. Root 2 square is 2. 2 plus 1, that is 3. So OD is equal to root 3. Now again you are going to put your rounder at point O. You are going to take your pencil up till D and then you are going to draw an arc intersecting the line at point Q. Same thing I have written over here. Now with center O and radius OD, draw an arc intersecting the number line at point Q. Point Q represent root 3. Exercise 1.2. This is true or false. State whether the following sentences are true or false. Every irrational number is a real number. The statement is true because the collection of real number contains all the rational numbers and all the irrational numbers. Question number 2. Every point on the number line is of the form of root m, where m is a natural number. The statement is false because the negative numbers on the number lines are never of the form root m, where m is a natural number. So you cannot get negative numbers. Where natural numbers are always positive. For natural number m, root m is always a positive number. Question 3. Every real number is an irrational number. Again, this statement is false. The collection of real number is made up of rational numbers and irrational numbers. So every real number is either a rational number or an irrational number. Question number 2. Are the square roots of all the positive integers irrational? If not, give an example of the square root of a number that is rational number. No. Answer. No. The square root of all the positive integers are not irrational. The square root of any perfect square number is always a rational number. Example I have given you. Square root of 4 is 2 and 2 is a rational number. Root 9 is equal to 3 and root 16 is equal to 4. Now show root 5 on a number line. That is, there are two methods to show root 5. Already I have shown you root 2 and root 3 before. Same way, this is called as spiral method, and second method is called as alternate method. So first of all, we are going to go with spiral method. Dear friends, same way, OA is equal to 1 unit. I have drawn AB perpendicular to OA so that measure angle A is 90 degree. So I have to find out the hypotenuse OB. Same thing I have written over here. On a number line, O represents 0. Represent A on the number line such that OA is equal to 1 unit and A represent 1. That is A is equal to 1. OA is equal to A is equal to 1. Draw a segment AB perpendicular to OA, where AB is equal to 1 unit. So AB is equal to 1 unit. So this is the hypotenuse. So drawing OB, now construct segment OB. That I have constructed a segment OB. So by Pythagoras theorem, OB is equal to root 2. That is, OB square is equal to OA square plus OB square. That is, OA square plus AB square. So OB is equal to root 2. 1 square plus 1 square. I have taken OA is equal to 1 and AB is equal to 1. AB is equal to 1. So it is root 2. Now similarly, what I am going to do is, remember it well and understand it well. Draw a segment BC of unit 1. So now from here I am going to take 90 degree. 90 degree, I have made a point using a protractor over here, and I have taken BC is equal to 1 unit, and then I have joined OC. So OC in triangle OBC. Triangle, measure angle B is equal to 90 degree. and OC is the hypotenuse. So same thing in words I explained. Well, draw a segment BO with a unit 1 such that BC perpendicular to OB and construct OC. By Pythagoras theorem, OC is equal to root 3. That is, well friends, you are going to write OC is equal to root OC square is equal to OB square plus BC square. That is root 2 square plus 1 square. Root 2 square is 2 plus 1, that is 3. So OC is equal to root 3. Similarly, again you are going to draw perpendicular CD to OC. Then you are going to draw CD perpendicular to OC. Well, I have made the point of 90 degree over here, placing the protector over here, and I have made it one unit. Joining DC. So I have to find out DC. So DC is nothing but, okay, OC square plus CD square. That is root 3 square is equal to 3 and 1 square is 1, that is 4. That is root 4. Same thing I have explained you over here. Draw a segment CD of unit 1 such that CD perpendicular to OC and construct OD. Then by Pythagoras theorem, OD is equal to root 4. Now from here again you are going to take 90 degree and you are going to draw DC is equal to 1 unit, and in triangle ODE measure angle D becomes 90 degree. So this is 90, so you have to find out hypotenuse. So hypotenuse OE is equal to OD square plus DE square. OD is root 4, so root 4 square is 4 plus 1, that is root 5. Same way I have represented it over here in words. Okay, well, that is, now draw segment DE for the unit 1 such that CD perpendicular to OD. Construct OE. Thereby Pythagoras theorem, OE is equal to root 5. Now with center O and radius equal to OA, draw an arc intersecting the number line at point P. Represents root 5. P is equal to root 5. That again we are going to do. You are going to place your rounder over here. You are going to take your pencil up till point E, and from there you are going to draw an arc which intersect line L at point P. So point P represent root 5. Well, I have explained you all the Pythagoras rules. Over here OC square is equal to OB square plus BC square, root 2 square plus 1 square. OC is equal to 2 plus 1 is equal to root 3. OD is equal to OC square plus CD square, that is root 3 square plus 1. OD is equal to 3 plus 1 and OD is equal to root 4. Same way about root 5. Another alternate method to represent root 5 on a number line. You are going to draw a number line. I have drawn a number line over here 0, 1, 2. So I have taken OA, right, and AP perpendicular to OA, so that measure angle A is equal to 90 degree. Same way on the number line, take point O corresponds to 0 or 0. So I have taken O corresponding to 0. Choosing the proper unit. Okay, I have taken this at 0 to 1 unit, and from 1 to 1 unit. So taking a unit, take a point A on a line L. So I have taken this point A on line L such that OA is equal to 2 units, 0 to 1 and 1 to 2. So OA is equal to 2 units. Construct AP. I have constructed AP which is perpendicular to OA. That means angle A is equal to 90 degree. In line such that AP perpendicular to OA. Construct OP. Then I have constructed the hypotenuse. Now, according to Pythagoras theorem, triangle OAP is a right angle triangle with measure angle A is equal to 90. So I have to find out OP. So now in triangle OAP, measure angle A is equal to 90. So by Pythagoras theorem, OP square, this is OP square is equal to OA square plus AP square. That is OA square plus AP square. So OA is equal to 2 unit, 2 square plus 1 square. 2 square is 4 and 1 square is 1. So it is 5. So OP square goes as square root. So OP is equal to root 5. Now same thing, by placing your pencil at O, your rounder at O and stretching your pencil up till point P. From there you are going to draw an arc intersecting the line L at point B. So point B is root 5. Okay, now with the center O and radius OP, draw an arc intersecting the number line at point B. Point B on the number line corresponds to root 5. So B is equal to root 5. Homework. Represent root 4 on a number line by spiral method and by alternate method. You are going to write the steps as I have shown you. Thank you.